So let's go. Let's start the. Here is my my MATLAB code.
Oh, you do MATLAB as well, yeah?
Yes.
Oh, perfect. Because maybe sometimes I will need that as well.
Okay. So let me please let me get the earphones maybe so that we can.
Okay, yeah, right.
Okay. Nice. So as I make it very. So the step turning back here so that when you will, let me just quickly repeat it. And by the way, we say that we want a polynomial p of x that has only real coefficients and that has the roots 1 minus 2i and I. And I told you that to do it we do p of x equal to x minus the first root multiplied by x minus the conjugate of the first root multiplied by x minus the second root multiplied by x minus the conjugate of the second root. Is that clear? Now if you expand it, it will give you x squared minus x multiplied by 1 plus 2i, okay, minus x multiplied by 1 minus 2i, and then you will have 1 minus 2i multiplied by 1 plus 2i. That will give you plus 5, okay? That you multiply this x minus I multiplied by x plus I will give you x squared minus plus xi minus xi. That will vanishes and you have minus x squared, which is plus 1. Is that clear? Now you reach p of x equal to, here you will have x squared, this is minus x and minus x, so it gives you minus 2x, right? But you have minus 2xi plus 2xi, that will vanishes and you have plus 5. This multiplied by x squared plus 1. If you expand it now, you get the polynomial that you needed, okay? That will be x to power 4 plus x squared minus 2x cubed minus 2x plus 5x squared plus 5. That if you rearrange, it's x to power 4 minus 2x cubed plus this is 5x squared, okay, plus 7 plus 6x squared, and final minus 2x plus 5. So this is the polynomial he wanted you to get. You can see now that all the coefficients are reals, right? And as we started from here, this and this are the roots, okay? Nice. Next question. Excuse me, I need to get the okay. Next question says find a line parallel to the plane x minus 2y equal to 0 and passing through the point 1, 2, 3. Okay, so what is the situation? The situation is that we have a plane like this, and the equation of this plane is x minus 2y equal to 0, okay? And we have some point here. The point has components 1, 2 and 3, okay? What do we want to get? Please give me 1 second, please. Okay, just a second. Okay, nice. I am back. So we just want to find the equation of the line that passes through this point and it is parallel to this plane. So what is such a line? The line will be this one. So we want to find the equation of this line. So basically, what do we know? What do you observe? You observe that if I take the normal vector of this is the normal vector of the plane, right? This no. What is there any question? This. Now the directional vector of the line is this one, right? Let me call it u. I will tell you that the equation, if we say that u has components, the u1, u2 and u3, so we don't know them, yes or not? And we also know that there is this point, this point here on the line. Let us call it a. We know that a has component xa, ya and za, and we know them, yes or not? You know from the theory that to get the equation of the line, the parametric equation of the line, the parametric equation of this line will be x equal to xa plus u1 multiplied by t. This and y equal to ya plus u2 multiplied by t, and z equal to za plus u3 multiplied by t. Yes or not? This is called the parametric equation of the line. So we already know xa, ya and za, yes or not? But we don't know u1, u2 and u3. To know u1, we need to know this vector, yes or not? Is that clear? But how can I get this vector? How can I get this the vector u? You see, what is the vector n? To get the vector n, when I have the equation of the plane, the equation of the plane is ax plus by plus cz plus d equal to 0, right? Any equation of the plane is this form, and the n vector has component a, b, and c. So for this case, a is 1, b is minus 2, c is 0. Yes or not? For this one, a is 1, c is 2, and a is 1, b is minus 2, and c is 0. Because this equation here, I can write it like x minus 2y plus 0z plus 0 equal to z. You can see that your a is 1, your b is minus 2, your c is 0. So n has component 1 minus 2z. I just need to take a vector u such that the dot product gives 0, right? How can which vector can I take such that the dot product gives 0? Yes, because you can see that n and u are perpendicular. U is perpendicular to n, right? When two vectors are perpendicular, the dot product should be 0. Yes or not? So imagine that you have component u1, u2, and u3. Doubts? This is u. It has component u1, u2, and u3. We are looking for them, right? How do you do the dot product of two vectors? You do u1 multiplied by 1 plus u2 multiplied by minus 2, right? Plus u3 multiplied by 0 should give 0. So it means that we have that u1 minus 2u2 should be equal to 0. So it means that you do what you want, but it's you can choose any vector you want. The only condition is that u1 minus u2 will be equal to minus 2u2 will be equal to 0. and then there is no condition on u3, so I can choose, for example, u3 equal to 0. If I choose u3 equal to 0 and I choose u1 equal to u2 equal to 1, what will be u1? I repeat, I choose u3 equals 0 and I choose u2 equal to 1. From this I get that u1, what will be u1? Yes, so my vector, yes, my vector u has component 2, 1 and 0. In fact, if you do the dot product with this vector and this, you get 0. Is that clear? Now that we get u, the equation of our line will be x equal to xa, which was, I remind you that it was 1, 2, 3. So xa was 1 plus u1, which is 2. So it is 1 plus 2t, right? Y will be first ya, which is 2 plus what is 2 plus t, right? Because this is 1. Is that clear? And finally for z, we'll have za, which is 3. So z equal to 3 plus 0t. This is the equation of the line. You got it, or I should explain again? Okay. Find the distance of the line this equal to 0 to this plane. So you have a plane and you have a line. You want to find the distance between that plane and that line. Okay? So let me check back the, excuse me. Yes, there is a formula. That's for the distance. So to review, let's first try to review a couple of stuff. Saying that with a new page. Okay, imagine that you are given a plane like this. Okay, and you are given any point A. I assume that the point A has component xa, ya, and za. Okay, what is the distance? Is this distance, right? Let's call it h, and assume that the equation of this plane is ax plus by plus cz plus d equal to z. How do you compute the distance from a point to on a plane? From a point to a, so the distance between A and the plane, let's find it. It's h, right? Yes. This height we can compute it by doing this. Look, I just take the I take the point A and I put it inside the equation of the plane. Okay, so it is absolute value of, it will be A time x of A, okay, plus B time y of A plus C time z of A plus D. Yes or not? What did I just substitute? Yes or not? And I divide by the square root of a square plus b square plus, here's the formula. Okay, now what happens is the same if I need to find the equation of a line, the distance of a line, because if I have a plane and a line, suppose that here is my plane, the line will be somewhere parallel, right? Otherwise the distance will be meaningless. I just need to take any point of this line. I take any point A belonging to the line, and I find the distance, and I will be using the same formula. Is that clear? It's enough to take any point on the line and find the distance. So going back to our exercise, we need to find a point on the line and find and apply this formula to get the distance, right? In our case, the equation we need the equation of the plane, and we need one point on the line. So go back to find. So we have the line. The line he gave us was x minus y equal to 2x plus z equal to 0. Okay? So the line is, just to repeat, the line is x minus y equal to, this is x minus 2y, no, this is, yes, x minus y equal to 0, and 2x plus z equal to 0. 2x plus z equal to z is the line. Yes or not? And the plane, I forgot to take the plane. The plane is given by x plus y plus z equal to 5. X plus y plus z equal to 5. Right? Now, what do I need to find first the point that belongs to the line. I need first to find one point that belongs to the line. To find one point that belongs to the line, I should solve, this is the equation of the line. So I should solve to find, yes or not? For example, I have x minus y equal to 0, and I have 2x plus z equal to 0. You see here that I have two equations but three unknowns. Yes or not? How can I do to find a point that belongs to the line? This equation here is called the Cartesian equation of the line. It's not the parametric equation that we saw before. The parametric equation used t, right? But the Cartesian equations use x, y, and z. But it is okay. So from the first we will just give me any point that satisfies the two equation. It is easy, and a point that can satisfy the two equation can be 0, 0, 0. Yes or not? This point satisfies the first. It's all satisfy the equation of this equation. Yes or not? So I can just now use, because now I know my plane. I have the line, and I just take any point A on the line, and I find this. Yes or not? This is the equation of the plane. So we said that to find the distance, we should put the point inside the, yes or not, the equation. So the equation of this plane is x plus y plus z minus 5 equal to 0. Yes or not? So it will be absolute value of x of a plus y of a plus z of a minus 5 divided by square root of how much is ABC? How much are ABC? Yes, of the planes we are finding. This is the formula. How much are ABC in this exercise? This is the equation. Yes, so this will be 1 square plus 1 square plus 1 square, right? So above this xa, ya, they are all zeros, right? Because we said that the point A is 0, 0, 0. So it will be absolute value of minus 5 divided by root 3. So it is 5 over root 3. Doubts? Is there any doubt? Okay. So this distance is 5 over root 3. Okay. Okay, find the canonical form for the following conics. Okay, so it is 4x squared plus y squared what? Yes, we did this 4. We are doing 4, right? Okay, find the canonical form for this conic. The conic is 4x squared plus y squared minus 4x minus 2y plus 7 equals 0. So 4x squared minus plus y squared minus 4x minus 2y plus 7 equal to 0. Okay, the canonical form of a conic, okay, it means that you should try to write this conic like x minus x center square over a square plus y minus y center square over b square equal to 1. Is that clear? Yes. This should be plus or minus according if it is an ellipse or, okay. If it is, this can be if it is an ellipse it will be plus. If it is an hyperbola it will be minus. So you will just do the computation and see what come out. So you see that here I need to get first I put the stuff with x together and put the stuff with y together. So this will become 4x squared minus 4x plus y squared minus 2y plus 7 equal to 0, right? I just put the stuff with x together and the stuff with y together. Now I factor because I just want to deal with x, so that's why I factor out 4. So we can remain here with x squared plus x plus I don't have y minus 2y plus 7 equal to 0, right? Okay, is that clear? Nice. Can you hear me? Yes, I didn't say anything. Okay, now when you reach here, please, this is a very old trick, but it is still useful. Look at what am I going to do. You agree that this is 4? Tell me. Yes, I am just saying. Now you understood till here? Okay, now I am saying that x squared plus x, I want to write it like a square, so I want to be able to factorize it. Is that clear? To do that, I say, look, look, this is x squared plus, instead of writing x, okay, this x I can write it like 2 multiplied by 1/2, yes or not, multiplied by x. Doubts? And plus y square minus this 2y, in fact it is 2 times y, okay. I mean 2 times excuse me, it is 2 times 1 times y. Excuse me, let me, because I want to be, you don't you will understand why we are doing all this stuff, because 2 times 1 times y, okay. then plus 7 equal to 0. Now what is the, look, this is like if you want to, if you identify this with a, yes or not, this will be a plus some kind of 2ab. You understand? Because you see, if this is a, this will be a square, I mean, yes or not, x is a square, x will be a, right? There will be this 2, right? So this means that b here is 1/2, yes or not? But in this case, what is, so this will be a square, right? Minus, you also see that there is 2a, which is y, right? And what is b in this case? 1. Then plus 7. But what do I want to do? Look, you know from high school that if I have a square plus 2ab plus b square, I can factorize. Or a square minus 2ab plus b square, right? That's why I want to write it like this. So I will write it like 4 multiplied by x square plus 2 over plus 2 times half times x. Okay, now I will add plus half and subtract plus half. Is that clear? Doubts? To the other, I will say plus y square minus 2 times 1 times y. I will add plus 1 and substitute and subtract minus. Is the same, right? Now look at this stuff. This part, what is it? It is a square plus 2ab plus b square. No, I mean, here I wanted to add 1 over 4, please, and subtract 1 over 4. Yes or not? So this part is a square plus 2ab plus b square. You can write it like, it comes from the one from half square. I will, no, this look complicated, but then I will tell you the trick. Yes or not? So now this part can be written like, this is x, this is a square plus 2ab plus b square, right? So if you can write it like 4 multiplied by x minus x plus, I mean 1 over 2 all square minus half minus 4 or 1 over 4. Is that clear? The same you can do plus y minus it's y minus 1, right? All square minus 1. Doubts? Plus 7. Now this will give you x plus half all square minus 1, yes or not? Plus y minus 1 square minus 1 plus 7 equal to 0. Like x plus half square plus y minus 1 square minus 2 plus 7, that gives minus 5, plus 5 equal to, is there any doubt? Let me, this is a bit, are we sure that this is no, this was minus, there was a minus, it was minus 4x. I don't know why this was minus 4x. By the way, look, this I made a mistake. There was in fact I wrote minus 4x, then I forget. No, it's correct. Yes, it's correct. Excuse me. It's correct. Right? I'm right. but even if it is correct here, this is minus, not plus, right? So this is minus, okay. Okay, and this is minus. I don't know, but there's something that is boring me. Because something is bothering me, because it will give x minus 1/2 square plus y minus 1 square equal to minus half. So this is 4 to minus 5, right? But the problem is that it gives you, we can divide all by minus 5, so it will give minus 5 over 4 x minus half square minus 1 over 5 is 5 y minus 1 square, right, equal to 1. You agree? There's something so, but by the way, you can write it like x minus half square, this divided by minus 5 over 4, right? You agree? Plus y minus 1 square divided by minus 5 equal to 1. These numbers are not supposed to be negative. I don't know why they come negative, because like this I cannot do the square root. Excuse me, let me check what was trovare una forma canonica che è la conica. I don't really know why they come negatives. They are supposed to come all positive. Tell me. By the way, you understand? Tell me. Yes. For example, if you have x squared minus 3x and you want to do this, the trick is very simple. You take x, then you take minus 3 over 2, okay? You square it, now you remove minus the square of this. Yes, but in fact it's the half of the number. So if I have, for example, y plus 4 y squared plus 4y, what is the trick? The trick is going to be y plus 4 over 2, which is 2, right? All square, then you minus the square of this, that's you minus 4. Here's the trick. It should work. Probably there is a mistake on the, so you should write, I am supposed, normally you should reach like this here without this minus, okay? And get that the conic will give you square plus y minus 1 square divided by the square root of 5 over 4 all square plus the square root of 5 all square, okay? That match this form. So that's how you do it. Questions? No. Okay, number 5. Please let me check something before going. Okay, just a moment, I have to reply very quickly to this email. Okay. Okay. Nice. Let's go back to, okay, we the next question is for which real value of h this conic here is an hyperbola. Okay, so we want this conic here to be an hyperbola. So the conic is x square conic is x square plus h square y square plus minus 4xy minus 4x minus 1 equals to 0. Right? I remember, so when you have a conic like this, to know if it's you have to write the general matrix of the conic. You know it, how to write it, right? So the matrix of the conic, here you have x, y, 1, x, y, 1. So this is for x square, that is 1, right? Then this is at this position you have y square, which is h square, right? Then at this position you have the number, which is minus 1. At this position here you have xy, and also at this position you have xy, right? And xy is minus 4. You split it in two minus 2 and minus 2. Yes or not? At this position here you have x, because it gives you x, and also this gives you x. So it will be x is minus 4, so it will be minus 2 and minus 2. There is no y, so we have 0, 0. So let me write better the matrix. The matrix is 1 minus 2 minus 2 minus 2 h 0 minus 2 0 minus 1. Here is the matrix of the conic. Okay, but how do when you have this matrix, there this big matrix is called the matrix B. This part is called the matrix A. To know if the determinant of b is equal to 0, we say that the conic is degenerate or degenerate. Okay, is degenerate, it means that it is not an ellipse, it's not a parabola, or it's not an hyperbola, that it is anything else. Doubts? But if the determinant of the big matrix, if the determinant of B is not 0, we have three possible cases. If the determinant of A is smaller than 0, then you have an ellipse. Okay? If the determinant of A is equal to 0, then it's a parabola. And if the determinant of B, this smaller than 0 is hyperbola, excuse me. Okay, and if the determinant of B is greater than 0, you have ellipse. Okay, so now we need to find so let's first find the determinant of B, the big matrix. If we solve for the determinant of B, we can use the second, which we can use the first row. I will use the third row to find the determinant because it has some 0. You know how to find the determinant, right? So if I use the third row, I want to find the determinant of B. It will be -2. This position here, it is position what? This is position 3, 1. Yes, 3, 1, so it is a positive position, right? But third row, first column, so it will be -2 multiplied by, I cancel this, and when with 0 -2h, so it will be h, right? I hope you're understanding. It will be 2h, I mean. You know how to compute the determinant of a matrix? Yes or not? And you're understanding what I am doing? Usually, which row do you use to find the determinant? The first? Which row do you use? How will you compute the determinant of this matrix? Okay, so the determinant in this case, I'm saying when you want to compute, so if I use this row, I cancel, it will be 1 multiplied by, I cancel, it will be -h minus 0, that will be -h, right? The next one, I use this -2. I put first minus, then I put -2. I cancel, it will be -1. I cancel, it will be, no, when I cancel this and I cancel this, it will be 2. No, look, I cancel this and I can, yes, so it is 2. Then I do the last is -2 multiplied by, if I cancel, it will be 0 minus 2h, so it is 2h. It is 2h because of the minus of the determinant. Okay, so it will give you -h, so the determinant will give you -h plus 4 minus 4h, right? Is that clear? This was h square, I think. This was h square. So it will be, this is -h square, and this is square, right? So it gave us -h square plus 4 minus 4h square. So it is minus 5h square plus 4, right? So we get that minus 5, this is the determinant of B, of the big matrix. We want it to be not equal to 0, because if it is equal to 0, the matrix will, the conic will be degenerate, right? So this means that minus 5h square, h square should not be equal to minus 4, right? So h square should not be equal to 4 over 5. So h should not be equal to plus or minus 2 over root 5, right? So these are the value that h should not have. So we know that but we now find, so h can be any number except 2 over root 5 and because okay, but this just means that if a is not 2 over root 5, this just means that the conic is not degenerate, right? Because we say that when the determinant of a is not 0, the conic is not degenerate. But you still have 3 cases. Remember that we want it to be greater than 0. So to be greater than 0, we should find that this is the determinant of a, right? We should find now the determinant of a. The determinant of a is a square minus hyperbola, right? Nice. Yes, thanks. So the determinant of a is actually h square minus 4. You can see. Yes or not? So we want h square minus 4 to be smaller than. No. This means that how do I solve this? It's a parabola. So this is h equal to 2 and h equal to minus. I have to draw it like this. So it cut at minus 2 and. Yes or not? It's a parabola. It will cut at minus 2 and 2. Yes or not? So we want it to, what is the solution then? Where is it negative? H square minus 4 smaller than 0. Look at the graph, and where is it negative? It's negative here. So the solution should be between excluded, because from minus 2 to. But in this interval, so if we want the determinant of a to be negative, h should belong to the interval from minus 2 to. But remember that a should not be 2 over root 5 and minus 2 over. We check, are they in the interval? Yes, they are in this interval. So h can be any number a belong to the interval minus 2 to 2, except the two number 2 over root 5. Right? These are the value for which we get the parabola, the hyperbola. So when you have this kind of exercise, you first find the value that h should not be, and then you find the value that h should be, and you check if they're inside. Okay? Oh, I am. So 6 says, find as h is varying, say how many solutions this system has. So you have a system depending on h, and they want you to discuss the number of the solution of the system as h is varying. Is that clear? Hello? Okay. Okay. New. Okay. The system is now we want you to discuss the number of solution of the system as age is varying. So you will want to age 1 4 minus h to h 1 h. Okay, x y z. Okay, here's the system. So probably they taught you that when you want to, you don't need to solve a system, you can write it like this. Yes or not? Then you need to reduce this matrix. So let's, why do I could choose anyone like the marker, but let's choose this one because it make my life easier, right? Do row 1 minus row 2 and row 3 minus, yes or no, to kill this one. So it will be 1h2 because this row doesn't change. Then it will be row 1 minus row 2 will be 0, 2 minus yes, so we are doing row 2 minus row 1, yes, h minus 2, right, and 0. Then 0, 4 minus h will be 4 minus 2h, 2h minus 2 will be 2h minus 4, right, and 0, right? Now which one is easy to take? We take any one as a marker, right? Let's take this one. To get this one, we need to multiply the row by 2, right? So can you hear me? Hello, can you hear me? So this come out to be 1h2 0 0 2 minus h minus 2 and 0. Then this is 0. If I do 4 minus 2h minus 2 times this, it will be 4 minus 2h minus 4 minus 2h, which is 0, right? 2h minus 4 minus 2, this is also 0. So we reach this, right? Now probably if last year you told me that this part is called the matrix A, and all the matrix is called this part is B, right? So all the matrix is the matrix A, B. Yes or not? Now I remind you that if the rank of A is not equal to the rank of AB, then no solution. Is that clear? But if the rank of A is equal to the rank of A of the matrix AB, then we have infinity to power number of unknown. Yes, n, which is the number of unknown minus the rank of A. Is that clear? So let's go and analyze. Now you reach you have to discuss the rank of A. For example, you can see from here that the rank of A is always equal to the rank of AB, yes or not? You can hear me now? Look, for example, that we need to discuss the rank of A according to the value of H, because A depends on H, right? For example, if H is 2, then the rank of A will be 1, and also the rank of AB fortunately will be 1, yes or not? And so they are equal, and we have infinity to power 2 solo. But if H is not 2, the rank of A will be 2, also the rank of AB will be 2, and we just have infinity to power 1, so solution. Pay attention that they what? Okay. Pay attention that they didn't tell you to, they just tell you to find to discuss the number of solo. The number, how many solutions. They didn't tell you to solve the equation, just to discuss the number as we did. So according to H, we tell the number of solo. That was the question. Okay. Question 7. Find a basis of the subspace of R4 generated by these vectors. When somebody gives you this kind of space and they say find the basis, you have to put them in a matrix, reduce the matrix, and take the one that are not that are not equal to the null vector. Is that clear? I say when you have this kind of subspace, to get the basis and the dimension, you need to put all this vector in a matrix and reduce the matrix. Can you hear me? Okay, so no, how do you reduce? Reducing the matrix means that you find the marker for each row. Yes or not? So let's put them in the matrix. So what is this? The vectors are, you can put them by row, by column. It's not relevant. So 1 1 0, 1 2 4 0, 1 0 minus 2 1. This is my matrix. Is it reduced? How do I know if a matrix is reduced? The matrix is reduced when for each row I have the marker. Yes or no? Do I have the marker for the first row? So which one is easier to make it a marker? The second. Yes, the second is the best one because it already have many zero below. So I just have to do row 2 minus 2 row 1. Yes or not? Doing row 2 minus 2 row 1, 1 1 1 0. This row will become 1 minus 2, which is minus 1, 2 minus 2, which is 0, 4 minus 2, which is 2, and 0 minus 0, which is, yes or not? The other rows remain the same. 1 0 minus 2 1 and 0 0 0 3. Now I have the marker for the first row, right? Now I want to make this guy the marker of the, it's minus 2. It was minus 1. I want to make it the marker of the row. To make it the marker, I just need to do row 3 plus row 2, right? It give me 1 1 1 0 minus 1 0 2 0, then 0 0 0 and 1, then 0 0 0 3. Finally, I should make this guy the marker, right, by doing row 3 minus 3 row 4, I mean minus 3 row 2. That leads to 1 1 1 0 minus 1 0 2 0 0 0 0 1 and 0 0 0 0. Okay, so I see that the rank gave me 3. So this means that the dimension of that space is exactly, when the dimension is 3, the basis will be made by 3 vec. Okay, the dimension of a space is the number of the vector that make the basis. So the basis in this case will be exactly the vector 1 1 1 1 1 1 z 0 minus 1 0 2 0 and 0 0 0 1. Is that clear? Here's the basis. Okay, now 8. Find the base for the range of the linear mapping defined by. So we have this linear mapping, and one needs you to find the basis of the range of that linear mapping. So let me write the linear mapping here. The linear mapping is given by f of x, y, z equal to x plus y, x plus z, comma, y plus z, comma 0. Yes or not? Anytime one has a linear mapping, you have to write it like x plus z, y plus z, and then z. From this you get the matrix of the linear mapping. Okay, the matrix of the what is be the first row? It's 1 0 1. Yes or not? 1 for x, 0 for y. Then the second row will be 0. Tell me. Yes, but it's this when you have a linear mapping, this is how you write the matrix. Yes or not? There is no y. There is no, look at the question is x plus y, so it is, so this is 0 1 1, and the third one is 0 0 0. This is the matrix of the linear mapping. Yes, obviously. Okay. Now, when you know the matrix, the image of the linear mapping is the space generated by the core. So it will be linear of 1 0 0 0 0 1 0 and 1 1. This is the image. Is that clear? Of the linear mapping. No, but the image is just the linear, the space of, yes, is the linear of each core. Is the space, is the set of linear combination of the column of the associated matrix. This is the okay, so this is how you get the image of a linear mapping. Now they say find the basis of the image. I already tell you that when you have a set like this one, to find the basis you put the stuff in the, so again, row or column, I don't mind. Putting them in row or putting them in column, I don't mind. Let's put them in row as we did before. Yes, the only thing is that when you will reduce, when you are taking place, if you put in a row, when you are taking the basis, take the base in row, the basis in row. When you finish, if you put it in column, when you will be taking the basis, take the basis in column. It's clear? So now that I put, I reduce, I always put by row. I like putting by row. So it's now I find the I don't have the, I find the marker for the first row, right? By just doing row 3 minus row 1. It will be 1 0 0 0 1 0. It will be 0 minus 1 and 0, right? Then I do row 3 plus row 2, right? It will be 0 0 0 0 0 1 0, and it gives 0 0 0. So we get that the dimension of the image is 2, yes or not? And also that the basis for the image, the basis are 2. If the dimension of somebody is 2, the basis is made with 2 vector. That is 1 0 0 0 and 0 1 0. Doubts? So from this we saw how to find the image of a set, to find the dimension of the image. We have to also find the image of a linear mapping. You write down the matrix, and the image is the linear of the columns. Then we saw how to find the dimension of the image and the basis for the image. 9. Given the matrix A equal to this, they want us to say if A is diagonalizable. Yes. Okay. Is 1 2 minus 2 1. So you are given the matrix A equal to 1 2. So we find the eigenvalue, we find the determinant of 1 minus lambda, right? 2 minus 2 and 1 minus, that is 1 minus lambda square plus 4, right? Isn't it? You agree? Okay. Probably you, I don't know how good you are in this stuff of doing algebraic calculation, but you see that I should solve 1 minus lambda square plus 4 equal to 0, right? But this typically, it doesn't have real solution, because you cannot sum a positive number plus another positive number and you get 0. To solve this, we use complex number, because this 4 you can write it like minus 4i square. Yes or not? Because I square is minus 1. Doubts? So it's like solving 1 minus lambda all square minus 2i equal to 0. Minus 2i square, So it's like a square minus b square equal to 0. A square minus b square means a minus, so this it will be 1 minus lambda minus 2i multiplied by 1 plus lambda plus 2i equal to 0. Yes or not? It's like when you have a square minus b square, it gives a minus b multiplied by a plus. So this stuff can, here this means that 1 minus lambda minus 2i is 0, or 1 plus lambda plus 2i is 0. Yes or no? So lambda is equal to, okay, here 1 minus 2i, or because I send lambda to the other side, yes or not? Or lambda is equal to minus 1 minus 2. So here these are the two eigenvalues. Look, in general, if the eigenvalue of the matrix are distinct, so they are not the same, the matrix is diagonalized. Okay, so this is a theorem. You don't even need to check anything. So I repeat, the theorem says that if all the eigenvalues are distinct, then the matrix is diagonalizable. Is that clear? But so if you compute the eigenvalues of the matrix and you see that they are distinct, then that matrix is diagonalizable. Or diagonal. Is that clear? But typically what so in general, but this is an easy way to check if the matrix no, I mean, if the eigenvalues are distinct, then the matrix is diagonalizable. But the matrix can also be diagonalizable when the eigenvalues are not distinct. So I am just saying that if they are distinct, then the matrix is diagonalizable. In this case, I got two distinct eigenvalues, right? Because this 1 minus 2i is not the same as minus 1 minus 2i. So I get two distinct eigenvalues, so that the matrix is diagonalizable. Now suppose I give you now a matrix A, another matrix A. If the eigenvalues are 1, 1 and 3, can I say directly that it is diagonalizable? No, because I have an eigenvalue which is repeated. Yes or not? We say in this case that the algebraic multiplicity of the eigenvalue 1 is 2. Yes or not? And the algebraic multiplicity let me write it like I call it the algebraic multiplicity of the eigenvalue 1 is 2. Yes or not? Whereas the algebraic multiplicity of the eigenvalue 3 is what? Is only 1. It comes only once. Yes? It's clear? Now for this matrix to be diagonalizable, also the geometric multiplicity of 1 should also be 2, and the geometric multiplicity of 3 should be. So the matrix is diagonalizable if the algebraic multiplicity of any eigenvalue is equal to its geometric mul. What is the algebraic multiplicity is easy. You just compute the eigenvalues and you count the multiplicity. Yes or not? If for example if the characteristic equation give lambda minus 1 all square multiplied by lambda minus 3, you can directly see from this equation that lambda equal 1 come how many times? 2 times, and 3 come only once. Yes or not? So the algebraic multiplicity is very easy to get. You just solve the equation and you see the number of times every. Yes or not? But how do I get? But you just solve like we solve here. And yes or not? Doubts? So getting the algebraic multiplicity of any lambda is easy. You write the characteristic, you solve, and you see. But how do I get the geometric multiplicity of how do I get, for example, the geometric multiplicity of 1? To get the geometric multiplicity of 1, I find the rank, okay, of a minus 1 times the idem. Is that clear? To get the geometric multiplicity of 3, what you will do? You will find the rank of your matrix. Is that clear? But why do I tell you that? I told you, look, this is a property. It's another theorem. Look, 0 is always strictly smaller than the geometric multiplicity of any lambda, and the geometric multiplicity is smaller or equal than the algebraic multiplicity. Is that clear? Of the same lambda. So what am I saying? I'm just saying that if this guy is 1, how much will be the geometric? For sure. That's why I told you that if you get distinct eigenvalues, if for example you compute and you get 1, -1 and 0, how much is the algebraic multiplicity of everybody? 1. And so the geometric will also be 1. You don't even need to check again if the matrix is diagonalizable. Yes or not? You got it? Look, that is why I told you I never solve a paper. I will never solve a 4 paper in 1 hour like you were saying. For me, it's a good stuff to solve 1 paper, but make sure that with using that 1 paper, you are able to solve 10. Because any stuff that we solve here, I am saying that for me, it's important to solve 1 paper and make sure that with that unique paper, you can solve 10 other papers. Is that clear? Because Amos will tell you probably, I am not the kind of guy that wants you to solve 10 billion of paper just to don't want. Probably I could do 100 hours with you. You pay me the 100 hours, and at the end of the 100 hours you don't know anything. But that is not the game. The deal is to make sure that you understand what I am saying. Is that clear? Okay. So because you told me that you want in 2 hours to solve 4 papers, or I don't know how, if you know person that do that, but okay. Probably text me so that you can text me tomorrow, and we decide what to do. Okay. Okay. Is there any question? Tell me. Okay. And I will send you this video about the stuff with it, and okay. Tell me. By the way, you have the exam. Yes, absolutely. I told you, write me tomorrow, and if I have any hour, first of all, focus on what we did now. Study it in